Welcome to another exciting episode of CCNA 1. This time we're in Chapter 7, Exploring the Network. We will be taking a look at your IPv4 network addresses, IPv6 network addresses, connectivity verification, and some other things that are thrown in there. A lot of binary to decimal conversion, hex to decimal, and so on and so forth. So we'll go ahead and get started here. With IPv4 network addresses, we'll be describing the types of classes of network addresses, what CIDR notation is, unicast versus broadcast versus multicast. So let's go ahead and get started. And our first section is on binary to decimal translation. Okay, or conversion, I should say. So we need to be able to convert from binary to decimal and vice versa, really. This is going to become pretty dang important when we get into subnetting. So we need to figure out or know how that works. Okay, so an address, an IPv4 address expressed in binary, you got just zeros and ones. That's what binary coding is. So a bunch of zeros and a bunch of ones. And that's how it would be written out in decimal. So how do we get from one to the other? Okay, I'm encouraged to just go ahead and ditch these slides and go into my own thing in Excel, which I think I will in just a second. But first, your dotted decimal address, that's what's referred to when you're talking about your decimal address up here. Each section is considered an octet. It's 8 bits. The total address is a 32-bit address in IPv4. So each section here, 4 sections, they're all 8 bits of ones and zeros. Okay, so this is referred to as dotted decimal. These different sections are referred to as octets for every 8 bits. Octo, 8 bits. All 4 of those together, we get 32 bits. Okay. So the next few slides go on to show you the process you could use to convert binary to decimal, talking about radix, this, that, and the other. As far as I'm concerned, radix is just Goku's brother on Dragon Ball Z. So what we're going to go ahead and do is take a look at an Excel spreadsheet. There's a chart you can make that makes converting these numbers pretty easy. Of course, you could convert decimal to binary with a calculator. That is an option, but not on your CCNA or CCNT exam. So you need to be able to do this by hand. So let's take a look at it. So here's our Excel spreadsheet. I'm going to go ahead and make sure I'm going to go on down here. So let's say we want to convert an IP address that's, we say the example is 192.168.1.163. Okay, just a random address that we got. We need to convert that to binary. So I found the easiest way to convert to binary, and of course it's not my method, it's just one I've been shown, is to use this chart. Okay, so you can do this if you have a scratch piece of paper. Just write out these numbers that I'm about to type in. Basically, first of all, you've got your octets. The maximum value of each octet is 255. Okay, so to get to 255, here's what you're going to do in terms of binary to decimal. You're going to make this type of chart. It's going to go 128 to 64 to 2, 16, 8, 4, 2, 1. Okay, I believe that's right. 1, 2, 3, 4, 5, 6, 7, 8. So basically what you're doing here is you got your 1, you got a 2, then you're going to have a 2 to the power of 2 to get your 4, 2 to the power of 3 to get to your 8, 2 to the 4 to get to your 16, so on and so forth. So basically this is 2, where's my up caret, to the 2 to the power of 3, and I won't make you watch me type this out. So there we go, chart complete. So you got 2 to the first, 2 to the second, 4, 2 to the third, 8 to the fourth, 16, 2 to the fifth, 32. Or if you just want to take the number you get here and multiply it by 2, you get the 4. 4 times 2 is 8, 8 times 2 is 16, times 2 is 32, 64. Anyhow, this is what you're going to write out for your chart. And that's going to allow you to convert any decimal octet to binary. Pretty simply. So here's how it works. So let's say we need to translate the 198 from our address into binary. Okay. What you're going to do is take this 198 and you're going to use this chart. Again, we're using just this area here. This is just kind of showing what we're doing. Okay. So that's the area we're using. All right. I'm going to say take this 198, start going from left to right, So can I subtract 128 from 198? I'm going to ask myself that. If I can, I'm going to place a 1 here. Okay, if I cannot, I'm going to place a 0. So I'll place a 1 there because I can subtract that 198 from 128. So what do I get in the end? I get 70. I'll say 198 minus 128 should equal 70. 198 minus 128. Oh, sorry, Excel needs an equal sign there. There, equals 70. Okay, so I've got 70 left. Can I take that 70 and subtract it from 64, or subtract 64 from it? Yes, I can. So I put a 1 here. Okay, and that just leaves me with 6. We'll trust our math on that. Okay, I've got 6. Can I subtract 32 from 6? No, I cannot. So I place a 0 there. Okay. Same thing here. 6 minus 16 does not work either. I place a 0 there. 6 minus 8 does not work either. I place a 0 there. 6 minus 4, yes. Okay, I can do that. So I'm going to put a 1 there. That leaves me with 2. I can take 2 minus 2, and that leaves me with 0, but anyhow, I can subtract 2 from 2, so I put a 1 there, and once you get to 0, then the rest are 0, so there's a 0 underneath the 1 here. Okay, so this string of ones and zeros is going to equal 198 in decimals. So I've got 11000110110. Okay, that's what I get for 198 using this chart to translate it. Okay, so that's how your binary conversion is going to work a bit. Let's try, well, I'll just try to go through the whole address. So go 168.1.163. Okay, so the 168, I'm going to take this. Can I subtract 168 from 128? Yes, I can. So I'll place a 1 there. I'm left with 40. Can I subtract 64 from 40? No. So I have 0. Can I subtract 32 from 40? Yes. So I place a 1. That leaves me with 8. Okay. Now that I know I have 8 left, I can pretty much just put a 0, make sure I put a 1 underneath the 8 because I'm going to subtract 8 from 8. Okay, so again, 8 does not subtract, 16 does not subtract from 8. It doesn't work. Okay, 8 minus 16 will not work, so we got a 0. 8 minus 8 will. That's a 1. So when 8 minus 8, excuse me, slow down a second. 8 minus 8 equals 0, so I don't have anything else to do here. I'm going to do 0, 0, 0 there for the rest of them. Okay, so my 168 is 1, 0, 1, 0, 1, 0, 0, 0. That's 168. Okay, in binary. The 1, well, there's only 1. 1 over there. So I'm just going to have a string of 1, 2, 3, 4, 5, 6, 7 zeros and a 1. Because I can't subtract any of this from 1 except for 1. So a bunch of zeros, then a 1. Hopefully that's making sense. Then the 163. Let me go ahead and wipe out what we've done so far here. Okay, the 163, you've got 128, 163 minus 128, that does work. that's going to leave us with 35. Okay, so we've got 35 left after we make that subtraction. 35 minus 64 does not work, so we have a 0. 35 minus 32 does not work, so we have a 0. 35 minus 16, I'm sorry, whoops, let me go back. 35 minus 32 does work, so that's a 1. My fault. So that's, yeah, 35 minus 32 gives us a 1 there. We have 3 left. Okay, so having 3 left, 3 minus 16, no, doesn't work. 3 minus 8, no, does not work. 3 minus 4, no, does not work. 3 minus 2, yes, that works. So we place a 1 here. We are left with 1 after that. 1 minus 1 works. So we place a 1 there. And there's our binary for 163. 101000011. Okay. So 101000011 is our conversion. So that chart should help quite a bit when you're converting octets from binary to decimal. We'll have to go just slightly further than that when we get into subnetting, but well, if we need to go further, we're going to have a 256, then a 512, and 1024, and go further and further if we need to. Okay, but that's basic binary to decimal conversion. And if it was going the other way, if I just had the binary value, okay, and I wanted to go the different direction, okay, so I need to figure out, well, I'll just have a random string of 11011, that's 5011. I think that's 8 digits, is it? 1, 2, 3, 4, 5, 6, 7, 8. So we'll find out what that means. Okay, well, same chart. I'm going to type my 1, 0, 1, 1, 0, 1, 1. Alright, now I'm just adding up to find out what this binary number means in decimals. So 128 plus 64 is 192. 192, we're not using this one because there's a 0 there. 192 plus 16 is going to be 208. 208 plus 8, 216. 216 plus 2, because we have a 1 here. 218 plus 1, 219. So that's going to be 219. Okay. So the chart will go both directions, whether you need to convert binary to decimal or decimal to binary. So that's what I use. You have the option of using. There's other techniques that are in the PowerPoint slides, but that will work just fine. Okay, we will have to come back to this a little bit as we go to hex. So let's get back to the presentation. We'll go past there. This is all conversion that we just did. So we really don't need any of this stuff. We can talk about IP addressing structure though. That is important. So we're here and still in IPv4 addressing, talking about the network and host portion of your IP address. So your IPv4 IP address is broken up into two sections: the network portion, which identifies the network that you're on, and the host portion, which uniquely identifies your device on that network. And how we determine how many bits are in the host portion versus, are in the network portion versus how many bits are in the host portion is through a subnet mask. So we'll be talking about that in just a second. So the subnet mask shows you how many bits are in the host versus network. Basically how it breaks down is in your subnet mask, the one we've been using mostly in classes, 255.255.255.0, which is probably, it is the most common subnet mask for home networks or small networks. It allows for 255 different hosts. Okay, so with your subnet mask, you got IP address, subnet mask. Any bits in the subnet mask that are ones, okay, that means that portion of the address is the network portion. Anything that's a 0, that means it's the host portion of the address. Okay, so we've got 255, 255, 255. That's all ones, all ones, all ones. That means the first 3 octets here, remember these are groups of octets, are the network portion of your address. The last portion here that's all zeros, that's going to be your host portion over here. Okay, so you need to know that the subnet mask, where there's ones, that means network. Where there's zeros, that means host. Okay. Concept that goes along with that is called ANDing. It's a process of determining or figuring out which network a particular device is on. So what that means is you've got the IP address of some device. Okay, we'll say it's some PC up here. Okay, you've got its IP address, and you've got the subnet mask down here. Okay, using those binary values, the binary value for your IP address, the binary value for your subnet mask, we can figure out what the network address is of the network that this device is on. Okay, and you do that through a process called ANDing. Basically, you compare the subnet mask to your IP address, and anytime you have ones that match, you would put a 1 down below. Anytime there's a mismatch or it's zeros, anything but a 1 and a 1 is a 0. You can see that in the table up here. Okay, so we'll take the ones there that match, we get a 1. Ones here that match, we get a 1. We got some zeros and ones that don't match, so those turn into zeros in the AND results. Okay. Ones that match, 1, 0, 1, 0, 1, 0, 0, based on the ones that match up here. Same thing there, same thing here. Okay. We don't have any matching ones over here. All right. So what we can do is convert these binary values back to decimal, and we'll have the network that this device exists on. So if you do that conversion, I could bring up my table again, but the first one would be essentially 128, the second one would be 64. You take those two and add them together, you get 192. Okay, and these combinations of ones and zeros is going to give you 168. That's going to give you 10, and of course this is 0. So that is the network address. That's the address of the network that this device exists on. Okay, so if you need to figure out what network a device is on, that's a technique for doing it. That's your ANDing technique, which you will probably be tested on. Okay, again, you're just comparing you're comparing the binary bits against each other and coming up with a result that identifies what network a host is on. That is ANDing. The prefix length, this is a way of showing a subnet mask in a shorthand technique. So you got a shorthand method of identifying a subnet mask. Basically, it's this slash some number, /8, /16, /whatever. That indicates the number of network bits in a subnet mask. Okay, remember all the ones stand for a network portion of a subnet mask. All the zeros stand for host portion. All right, so you've got a /8 here. That means you got 8 ones, or written in decimal, that would be a 255. Okay, a /16 means you have 16 ones, or 255.255. Okay, 2 octets of ones. 2 octets of ones. /24, which is pretty common, means you have a 255, 255, 2550, or 3 octets worth of ones. And you just go on down the list. So instead of writing the subnet mask out as this, you could write in a /24 /this /that in some cases. So that's how you're going to identify the network bits inside of an IP address. Okay, so we'll talk a little bit more about this later when we talk about CIDR notation in this lecture. This lecture looks like it's going to get pretty long, so here we go. Let's keep moving. All right, this slide we were discussing the network host and broadcast addresses inside of a network. So definitely items you're going to need to know. So we've got the network address. We've got a 192.168.10.0/24, which means it has a subnet mask of 255.255.255.0. If you remember from the previous slide, you can see the /24 is our normal, I guess, quote unquote normal subnet mask of 255.255.255.0. What does that mean? That all of these bits are taken up by network address, or the network portion, and the last 8 bits are the host portion, which means we can have 254 hosts. 254 hosts. Okay. So, why is that? Because 2 addresses in the network range, which is 256, are reserved. So you've got a reserved address for the network address itself. That's the network address, or the address of the network. Okay, you can't use that for a host. It's the first address in a network range. So you've got a 192.168.10.0. That is your network address. No device on the network can have that address. Okay, your first available host address is going to be the .1 address. Okay, and that typically would be given to your default gateway or router, which is the same thing, on your network. Okay, so that's typically going to be the address of your default gateway. If you don't have a default gateway, then maybe you assign it to something else. And in some situations, you would use the last host address in 254. Some people will use that as their standard, but mostly you'll have the first available address as your router. You've got a broadcast address. So if you want to send a broadcast in the network, that's the last available host address on the network. So in this case, 255 is the broadcast address. Okay. I shouldn't say last available host address. This is the last available host address. It's the last address in the network range. That is your broadcast address. Okay, cannot be assigned to a host. It's reserved for broadcasts. All right, so again, the first address in the range is the network address. Last is the broadcast address. Everything in between, those are assignable to hosts. Okay, so hopefully that's clear. Moving on. So your network address, again, is the first address in the network range. In this case, 10.1.1.0. And you can see that situation that I just explained comes up, where you would assign the first available address, which would be 10.1.1.1, to your router, and then you just got some other addresses assigned to your different devices in the network. So there is that. Your host address could fall anywhere within that range between the network address and the broadcast address. All right, so you got your first host and last host that are available. It's showing you those addresses broken down into binary. And then you got your broadcast address, which is the last address in your network range. So you can see that there. All right, so we've got Unicast, broadcast, and multicast, which we have talked about a little bit already. All right, here we go. So Unicast, broadcast, multicast. Unicast first. Here we go. Setting up a static IP address. We've done that in class a couple times at least. So you know how to do that, hopefully. Setting up a dynamic IPv4, just using DHCP to assign addresses to your hosts. So we've got Unicast, which is one-to-one, multicast, which is one-to-many, and broadcast, which is one-to-all. We've talked about that as well. So let's break it down a little bit again. Unicast, used for normal host-to-host communication. Sorry, my volume's raised a little bit. I realize I will take it back down. The Unicast address is applied to any device that's referred to as the host address. And the source address of any packet is always the unicast address of the originating host. So it's just a one-to-one communication. The source going to be the device sending. The destination is the destination device. That's pretty much all there is to it. Okay. So you've got a unicast transmission. You've got your broadcast transmission. So your source is going to be your end device here. Your destination is going to be 255.255.255.255 for a limited broadcast transmission. Okay. I know we just talked about a broadcast reserved address. All right. So we did talk about that. And you would think if this network had a normal subnet mask of quote unquote normal subnet mask of 255.255.255.0, why wouldn't you use 172.16.4.255 for your broadcast? Well, if you're doing a limited broadcast transmission that's just inside your local area network, then you're going to end up using this 255.255.255.255. Okay. If you're trying to do a broadcast to a remote network, okay, so if some PC over here outside the network is trying to broadcast to this 172.16.4 network, then this computer outside the network would send a destination packet of 172.16.4.255. That is called a directed broadcast. Okay, so you've got a limited broadcast within your own local area network. You've got a directed broadcast. If you're outside of a network and you want to broadcast to it, that's when you'd use that broadcast address that we saw earlier. Okay, moving along. So for a multicast, you just want to know the range that's associated with multicast transmissions. Some computers or devices on your network need to have subscribed to that multicast group, and based on that group's IP, you will send out your packet, and just devices in that group will get it. All right, IPv4 continued. We're almost to IPv6. I think I'm going to split the video at that point. Okay, so moving along. You have both public and private IP addresses, which we've discussed in class. You can see that these are the private IP address ranges, and memorizing what these ranges are is going to be important. Probably test questions on the CCNA and the CCNA, so you'll want to know those ranges. All right, so the 10 is a /8. The 172.16 through 172.31.255.255 is a /12. Okay, and then you have a /16 for 192.168.0.0 through 192.168.255.255. Okay, that doesn't mean that the networks need to have those subnet masks. In fact, most of the time with your 192.168. Yada 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 yada, you have a /24. That's just the general range that those private addresses can exist in. They're reserved for private addressing. Okay, so know those ranges. Know those ranges. You also should know the range of loopback addresses, which is just used to test your TCP/IP protocol stack on your computer. Basically, you're essentially pinging yourself to make sure that your TCP/IP stack is functioning correctly. Okay, you've got a link local address or an automatic private IP address, a PIPA. That's typically given to your device when you can't get off your network, or you don't have access to DHCP. So your device is just going to assign itself a local address so that it can communicate locally, even though it's not getting an address through DHCP. So that's typically 169.254.0 through 169.254.255.254. So if you see 169.254 and they ask you what it is, it's going to be a PIPA, is what they'll refer to it as. You also have test net addresses, which are used for testing. Okay, so know that range as well. So we've got these legacy classful addressing blocks, which used to be used but were pretty wasteful. Basically, before we had classless interdomain routing, which is CIDR. Okay, we'll talk about that on the next slide. You had classes of IP addresses, and based on how many addresses you need, you'd get a certain class of IP address that you could assign out or for your networks. Okay, so if you needed, I don't know, let's see. We've got, for instance, maximum number of hosts for a Class C address is maximum number of hosts on a Class C address is 254. Okay, let's say you needed 500. Well, you'd have to go up to a Class B address, and you'd have a maximum number of hosts of 65,534, which means you've got about 65,000 host addresses that are wasted out there. Okay, and we have gone over the issue of IPv4 running out, so this was pretty wasteful. That's why this is legacy and not really used anymore, but it may come up in tests as if this is a such and such address, what class would it belong in? Okay, so know those ranges, which are 0 to 1 through 127, 128 through 191, 192 through 233. Those are the ones you're going to want. And you can see the number of hosts per network for each one. 16 million goes down to 65,000, goes down to 254 for the different classes. Okay, so instead of using that, which is wasteful, we use classless interdomain routing, or CIDR notation. That was that slash this or slash that we saw. We saw slash 24 to indicate a subnet mask of 255.255.255.0. We saw a couple other slash numbers those are CIDR notation. Okay, that's what those slash numbers are. So we've got the different assignment of IP addresses through these bodies, and I guess it doesn't really show you. So let me go back up to the slide that had the CIDR notation on it. So it was this. Okay, slash this, slash that. That identifies how many bits are network bits, how many bits are host bits, and how many hosts you can have on a network. It's just a much better, less wasteful process than using that classful legacy that we saw. Okay. And now we're to IPv6, and I'm going to split this video here.